たち渋谷キューズが、今回共催という形で協力させていただいているので、渋谷キューズ、本日いらっしゃっている場所がどんなところなのかというところをちょっとご説明させていただければなと思います。ちょっと少しの時間だけお付き合いいただければと思います。よろしくお願いいたします。で、はい、まず私たち渋谷スクランブルスクエア、今日来ている建物なんですけど、こちらが、東急と JR 東日本、東京メトロの3社の合弁事業で成り立っている会社となっています。本日お越しいただいている渋谷キューズは、そちらの15階渋谷駅の直結直上にあるというものになっています。で、私たち渋谷キューズ、QWS と書いてキューズと呼ぶんですけど、これなんだと思う方もいらっしゃると思うんですが、Q、Question with Sensibility、問いの感性というところの頭文字を取って渋谷キューズとさせていただいております。で、渋谷キューズが、3つの特徴がありまして、1つ目がスクランブルソサエティ、コミュニティですね。で、2つ目がプログラム、3つ目が本日いらっしゃっているリアルな場というところになります。で、私たちは渋谷から世界を問いかける可能性の交差点というところをコンセプトに置きまして、ビジネス、スタートアップ、マネタイズだけじゃないよとか、ソーシャル系のところで領域を限定しない新しい社会価値の種と私は呼んでいるんですけど、よく言う01を満たすための施設、競争施設として運営させていただいております。で、3つある中の特徴の1つ目、コミュニティなんですけど、こちらが、大きく今回ご紹介する3つのメンバーシップから成り立っておりまして、1つ目がキューズプロジェクトメンバーというところで、こちらで問いを起点に活動していただいているプロジェクトのことを指しているんですけど、これまで150、160以上のプロジェクトが誕生していて、領域を限っていないというところで、コミュニティ型、プロダクト型、リサーチ型とか、ものを作ったりとか、思想を伝えたりとか、サービスを作るみたいな、いろいろなところで活躍をする方が、こちらで活動していただいております。で、今まで最年少で14歳、最年長で91歳というところで、かなり幅広い年齢層の方に活動もいただいていて、本当に多様なコミュニティというところで、こちら活動していただいております。で、そんなプロジェクトメンバーを支援してくださっているのが、キューズコモンズという支援者コミュニティがいて、今100名様ぐらいいらっしゃっていて、企業の経営者さんですとか、企業で成功されている方、投資家の方、それこそアートの方とか、いろんな方々に支援をいただいていて、こんな面白いコミュニティが成り立っているというところになっています。で、企業さんにも多く入会していただいておりまして、様々な企業さんが新しい事業を作り出すとか、そういったモチベーションでこちらで活動されております。面白いところが、カオさんとライオンさん、通常だと競合と呼ばれるところの会社さんも一緒に入居されていて、活動されているというところが、キューズのちょっと面白いところになっているのかなと思います。で、次、2つ目、プログラムというところのご説明をさせていただきます。で、なんといっても一番特徴的なのは、キューズ6大学さんと連携をさせていただいておりまして、そちらで、プログラムというところを提供させていただいているというのが、本日お伝えさせていただこうかなと思っているところです。で、この一番左上のキューズアカデミアと書いているものなんですけど、こちら今いらっしゃってクロスパークと呼ばれている場所で、知とのセレンディピティという言い方をさせていただいているんですけど、大学で研究をしているだけだとちょっと埋もれちゃっていたかもしれない。そんな知識とうっかりここで、こういったふうに、マイクでオープンなところで話しているので、うっかり出会えちゃうかもしれない。そんなイベントを毎週水曜日の夜にこちらで行っているところが特徴的なところです。で、そんな、キューズで活動したいみたいな方を応援するために、公募制の制度も3ヶ月に1回募集しているので、ぜひご覧いただければと思います。キューズチャレンジと調べれば出てくるので、ぜひご参加ください。最後、3つ目、リアルな場というところで、大きくこちらの4つ成り立っていて、今いらっしゃるのが右下のクロスパークというところになっていて、こちらだと今をイメージして、かなりゆったりとしたところで活動ができるというところと、プロジェクトベース、こちらが活動の本拠点みたいなところなんですけど、こちらで、活動をいただいたり、奥には200名規模のスクランブルホールというところがあったり、サロンと呼ばれる、支援者コミュニティの方がいらっしゃるというところの4つの場所で成り立っています。ぜひこちら今日いらっしゃったのでご覧いただければと思います。はい、それではキューズの説明は以上となりますので、こちらからイベントを始めさせていただきたいと思います。それではよろしくお願いいたします。
皆さんこんばんは。それでは早速、こちらのトレジャーハンティング2022年の、プロジェクトレポートについて発表を始めさせていただきたいと思います。私は本日司会と進行を務めさせていただきます東京大学 DLX デザインラボ特任研究員の内倉と申します。よろしくお願いいたします。まず今日の、会についてなんですけど、先ほどQ&A+の山口さんからもご説明あったように、今回はデザインアカデミーという、この組織は DLX デザインラボが、生産技術研究所、それからイギリスにありますロイヤルカレッジオブアートと連携によって運営している社会人向けのイノベーション教育プログラムになるんですが、この一環としてトークイベントを今回キューズ様と協賛でやらせていただいているという運びになります。まず最初にちょっとデザインアカデミーで近日公開予定のプログラムがいくつかありますので、そちらのご紹介をさせていただければと思います。まず1つ目はデザインアカデミーの大きなコア活動としてオンラインのワークショップを今開催しているんですが、1つ目はイスラエルにありますベザレル芸術デザインアカデミーから講師のロネル・モール先生をお招きして、ユーザーエクスペリエンスをどのようにこういう方程式として解けるかということを2日間ですね、のオンラインワークショップで開催していただきます。でロネル先生はデザイナーとして実務経験を積まれながらまた教鞭を取られる中でこの方程式を確立して、それを今回ビジネス、それからエンジニアの人たちにも分かるような形でご指導いただけるということで、日常の業務へも応用可能なプログラムになっているんじゃないかなと思います。そして2つ目は、これはもう少し先のプログラムになるんですが、英国にありますロイヤルカレッジオブアートのサービスデザイン学科長のクライブ・グリーニャ先生をお呼びして、今回は3日間の、オンラインショートプログラムを行う予定です。でこちらはサービスデザインに、関するコースになるんですが、クライブ先生は、現在もデザインコンサルタントとして英国政府、それからバークレーズ銀行、シスコ、オレンジなど数々の企業を、組織をリードされております。なのでこのプログラムに関してもその実績をベースに、構成された理論とビジネスへ応用できるようなそのようなプログラムになっております。そして3つ目、最後になるんですが、3つ目は東京大学から掛日康明先生にお越しいただいて、掛先生はインタラクティブメディア研究者、そしてアーティストとして活動されている先生なんですが、デジタルインターフェースにモノ的な質感を与えることによってこれまでにない新しいインタラクションを作り出すというようなデザインワークショップを行っていただきます。で掛先生のワークショップは1日の9月29日の開催になりますが、こちらもぜひご興味ある方はウェブページからご覧いただければと思います。今のご紹介したすべてのプログラムの詳細はこちらのウェブページにございますので、ぜひ後ほど詳しく拝見していただければと思います。それでは今日のこのトークイベントの内容に移りたいと思うんですが、まず簡単にこのトレジャーハンティング2022というものの概要、それからそれを行っております DLX デザインラボの概要についてご説明したいと思います。今日の流れなんですけど、概要説明ちょっと時間をしちゃってますけど、その後すぐ3部のプレゼンテーションに移りたいと思っております。今日は全体で6名のスピーカーの方にお越しいただいております。で最後にポスターセッション、それからネットワーキングという形でちょっと Q&A 全体で取ることはないんですけど、この後この各テーブルにそれぞれ回っていただいて、それぞれのスピーカーの方とお話をしていただければなと思います。それから途中でブレイクを取る予定なんですが、そちらにありますキューズさんのカフェが8時まで運営されているということだったので、ぜひこの休憩中にちょっと飲み物を買っていただいて、また飲みながらカジュアルな感じで聞いていただければと思います。すみません、ちょっと前置きが長くなっちゃうんですけど、このトレジャーハンティングというプロジェクトは DLX デザインラボという東大の生産技術研究所の中にある組織で行われているプロジェクトの一つになります。でこの中がこういう形なんですけど、研究者が行っている研究の種にインスパイアされたアイデアをまず高速でプロトタイプして、それをすぐにテストして発展させていくということが目的になっているデザインスタジオになります。で現在は学生、それから研究員、それからフリーランスのデザイナーなどを含めて約20名ほどで活動しているチームになります。でこの生産技術研究所という場所なんですが、 120を超えるさまざまな科学からエンジニアのデザイン方々、研究者の方々が研究室を持って集まっている研究体の組織になります。でその中でデザイン組織として DLX デザインラボは何かデザインすることを通してその研究と社会の橋渡しになるような活動できないのかなということをやらせていただいております。その一つのコアとなるプロジェクトが我々がトレジャーハンティングと呼ばせていただいているプロジェクトなんですが、政権の中にある研究者の皆さんと共同してデザインプロジェクトを行っていくそういう立て付けのプロジェクトになります。で今までもいくつかバイオコンピューティング、脳細胞の培養をされている研究室と共同で行ったバイオコンピューティングの未来のプロトタイプ作りですねから、これは毛細血管のセンシングを研究をされている研究室と行った日々のモニタリングができるようなプロダクト、そして自動車の研究を行っている研究室もあるんですけど、より自動運転車とドライバーの人たちがどういう信頼関係を作れるのかっていうのを実際のシミュレーターの中でテストするようなそういうプロジェクトも行っております。これまで合計で20個以上のプロジェクトを、期間はさまざまなものがあるんですけど、行わせていただきました。でこれらの一連の活動、それからトレジャーハンティングの概要がまとまっている本を昨年作成しました。こちらの QR コードからはそのデジタルバージョンがフリーでダウンロードしていただけますので、ぜひご興味ある方はご覧いただければと思います。すみません、その後、それではそのトレジャーハンティングの今年の2022年のプロジェクト、どういうものをやってきたかということになるんですが、今年はまず10個のリサーチラボと一緒にスタートさせていただきました。そのうち6つの研究室とコラボレーションを今させていただいているという状況になります。でその中で今日は6名にトレジャーハンターの方に来ていただいてますが、この黄色オレンジでハイライトされている3つの研究室ですね、3つの研究室、それから合計6個のプロジェクトを今回のトークイベントの中で共有させていただきたいと思っております。今日来ていただいているトレジャーハンターの皆さんなんですが、4名、ちょうどこの5月から7月の中旬までですかね、約2ヶ月半ほどイギリスにありますロイヤルカレッジオブアートから DLX デザインラボに4名の学生に来ていただきました。それからシエンさんとケンタさんはDLX デザインラボの修士2年生の学生になります。で今日はこの6名の方にそれぞれの研究室と行っていただいたプロジェクトの成果発表ということでやっていただきたいと思います。それでは早速トップバッターのシャオリンにここでマイクをお渡ししたいと思います。
Okay, so the purpose of DLX Design Lab is to create value through design. And what we do is that we work with researchers here at the Institute of Industrial Science and try to discover interesting things that they're working on, and using design process to create tangible ideas that somehow bring value to the researchers' work. And we call this process treasure hunting, because we consider that evolving knowledge and that new research to be a kind of treasure within the research labs. Why don't we have a look at one example of treasure hunting, where two DLX researchers went to work with Yamakawa sensei, who looks at high-speed optics and robotics.
山川研究室では高速画像処理、高速視覚フィードバック、高速ロボット制御を基盤技術として人間を超える新しい高速な知能システムを開発実現しています。シャオリンさんとは今回私たちのラボで持っているモーションキャプチャーシステムとモジュラー設計とを組み合わせて新しいアプリケーションである ビリーを開発いたします。ビリーはプロスポーツ選手に信頼性が高く効率的で安全性の高いトレーニングシステムとなることを願っています。
Thank you. And then is my own part, which is name is Village System. Let's continue the. I was Yamakawa Sensei. I'm in the Yamakawa lab right now. Using Yamakawa lab's algorithm, really produces errors of 0.1 millimeters or even less. Then the high-speed camera takes exactly 1,000 pictures for each second, which will then be used to record and analyze athletes' professional performance. Let's demonstrate a reaction exercise with Willy using Kendo. Willy will be tracking all the key informations via markers. Kendo is a modern Japanese martial art. We choose a real basic warm-up exercise named Jugi Boli. It's done by Kendo players to boost their performance during their practice. And here is the rules. 2 balls will fall down together, and the players has to hit the black one. This will lead us to 3 different observations. If you fail to hit the black ball, it will be considered as a miss. Once you hit the black ball with a certain speed, it will be considered as a hit. If you hit the black ball with accurate speed, it means you have a score. Okay, high speed. And let's start. Okay, so my project is about practice is the foundation of athletic success. Here we got a star here, which is 5 stars, which is quality, perspective, consistency, practice like you compete, and experiment. My project is mainly focused on the experiment. As an athlete, is to experiment and try new things. Experimentation is uncomfortable all the time because new things are unfamiliar. They don't feel good, and they don't usually work right away. Yet despite those obstacles, for you to achieve your sports goal, you must be open and motivated to try new things. And physically, technically, mentally, with your equipment and the team. And according to the research, it is reported that over 60% of injuries occurring during the practice, and over 20% of the injuries kept athletes from play for 7 or even more days. And now, let's look at the basic example from how will we use Yamakawa Lab's superpower to help those athletes.
We demonstrate a collaborative peg and hole task, in which the radii of the peg and hole are 6.350 millimeters and 6.325 millimeters respectively. We achieved peg and hole with high accuracy by using the developed human-robot interactive system.
Okay, so we can use those technology. So we capture the key joints for each particular sport. And then we can analyze the posture analyze. Here's an example of the gait with clinical validated marker sets for lower body, full body, and multi-segment model directly. We can track in basically everywhere of your whole body. And then is what do we really need for high-speed camera? Let's look at the men's 100 meters world record since 1977. As we can see, the second place and the third place, their performance is only 0.01 seconds, which means every millisecond matters for them. And here is what the marker set is. So what is the marker? It is the precise sphere with 3M reflective material. So if you wear that, the system will always know where you at and where the point at. And that is our capture suit. Markers can be attached to it, and it is customized for the set and for the skeleton. After we get those data, how do we deal with it? It's because we capture it, we record it, and we have to analyze it because we want our athlete to be better. And then is how and what is Willy. Willy is actually a highly sports customizable system to help professional athletes to train and record sports data when they have daily practice. I will take an example by the sport of the baseball. which is very popular in Japan, and another is the kendo. Here is some traditional kendo training process, and what can really actually improve is basically those 3 parts: basic movements, bearing movements, and movement correction. And here we can see from the tracking system, we can always know where the sword is and where the ball is. Let's see a very short video to show how do we know that. From here, we could see like the purple one is how I waving the sword, and it's coming lower to the ground, but it's okay, it's coming up. And the white one is the ball. It's not that stable. And after we get this data, how do we use them? This is a tracking GUI made by Yamakawa Lab. Hinano Sensei helped us, thanks to him, to build this GUI. He can directly analyze the data from the motion tracking system and can react due to the actual performance of the player. So we can see here, we can start, we can launch, and the delete workers, delete the images. It's not very complicated, but it's very useful. Let's see how do we work. First, we click launch here, and system will tell us it's ready. When we score, it will tell us score again. And let's look at it again. This is my only score during like 5 minutes. I'm a really bad kendo player. Yeah, anyway, the system know that I'm scored because I hit the ball really hard with a very high speed. Okay, since we know this data, we have the time, we have the position, then what do we get? We have our general performance. We have the actual distance that you actually move. We have the reaction time. We have the speed. And we can see whether your action is correct or not. Sometimes in Jugi volley, we have to do this. But if you do this, the system will know that. And we can analyze that to test if your Jugi volley is like correct or not. Okay. So let's make another example. It's not always about like hitting the ball. It of course can do other things. For fencing, in different rules, we have to hit a particular position to score. So we can have another rule, which is you closer to the middle point or the hitting point, your point will be higher. If we take this stick to be example, for example, in the middle part, if you hit that in really hard and accurate, you could get 5 points. And if you're hitting the tip, you're like 1 point, which means your performance is not as good. And then is only like fencer or like kendo player can play that? Of course not. They all can use that. How do we do this? And this is my set. And finally, I will introduce you Shaolin. Shaolin is my name. I know it's weird, but anyway. Sorry, I will. Give me like 1 minute. I will. Okay, so the Shaolin, I have to take the computer here. So basically, this is the basic part where we have the stick here. We have stick. If you're not happy about it, you can always, sorry, I can't use this. Like if you're not happy about it, you can take a marker and stick to there, and now it's our performance stick. And if you want the sword, of course, you can take it off. You can insert that, then it's a sword. And why do I design it in this way? Because our average length of this part is 10 centimeters. This is a rigid body. How to create a rigid body? We have to use 3 points to create a rigid body. Because if we hold in this part will be invisible. And the system will always know according to those 2 parts. So the rigid body is confirming that the system will always know like where our stick or our sword is. Oh, let's show you how to hold this for like. And another one. Why the suit is like this? Because if we wear like the whole tracking suit, it will be not comfortable for players. It will like interfere your motions. So, but we still have to track for some major joints. So you can just wear that, And of course, why do we have 3 points here? It is for our rigid body. So if we got the band, we got this, and then we got the ball. Like basically, you can do everything that you wanted to. Okay, the last one is acknowledgement. I've got so many people to thank. I think I have to thank for everyone and for everything. ありがとうございました。Okay.
Thank you. Okay. Hello, guys. So to start off my presentation, my name is Mara Isabel Asahlani. I'm from the GID course at the Royal College of Art and Imperial College in London. Through DLX, I worked alongside Yamakawa Lab on this project. Thank you to Yamakawa Sensei, Hirano Sensei, Savio, Kao-kun, Fu-kun, and Fan-kun for their input and support. Okay, so I would like for you guys to imagine a few scenarios. So what if your interactions online were designed to read the opposite way? And what if you had multiple letters missing from your keyboard? How would you adapt? And what if you had the choice of using only one keyboard layout your entire life? How inefficient would writing and communicating online be? Especially since we now have so many digital writing systems, we know the importance of well-designed communication tools. These digital communication innovations were developed with Latin script in mind. The keyboard keys are organized in a way that benefits that specific writing system. However, other languages, such as the Arabic script, have not advanced in the same way. Other languages have had to reform their entire script to keep up. Arabic did not keep up with the technological innovation due to the complexity of the script. And as a consequence, Arabic speakers use digital writing systems that are calibrated for Latin script. The complications of the script have to do with the decorative nature. Although seemingly complicated, it actually makes reading easier. The diacritics, which are basically the dots and the added signs to the individual letters, actually make it easier to read, so they indicate how to read it. And without it, the script wouldn't be legible, so you wouldn't actually be able to understand how to read and write something. So, and the connectedness between the characters also creates a huge character set. So if you can see here, one character would need a final, a medial, initial, and an isolated form to basically create a sentence. And so this is clearly not very suited to a regular keyboard. So throughout the script's development, it has been used to beautify Holy Scripture. And as a consequence, it's also seen as sacred, which means that the script has not developed past its calligraphic stage. So these gaps in development has led to poor Arabic reading and writing development in kids, and bad writing and spelling habits in adults. So an example of this would be this, Arabic and Inglisi, which is basically English in Arabic, and it's created this thing called Arabizi. So this is basically used in a lot of kind of text and online situations because the Arabic speakers had to use Latin characters to imitate Arabic because it just wasn't available. So this brought me to this question. Abled Arabic speakers find the current keyboard inefficient, but what about disabled natives? You may think of voice recognition input as a solution for most disabilities. However, it has limitations. It is vulnerable to ambient noise, it has privacy problems related to being overheard by others, and it does not support those who have speech disorders or those with impaired hearing. So how can we preserve the complexities of human innovation in this technological age, and how can we use technology to serve our needs without compromising the socio-cultural context? And what if we don't want to simplify the script by removing all the character, the tradition, calligraphic development, human craft, and history attached to it? So let me introduce Invisiboard. It exists within these constraints and aims to find a balanced design solution. It is the proposed non-touch, high-speed digital communication solution for Arabic script and less abled Arabic speakers in collaboration with Yamakawa Lab. I used their specialisms such as high precision, high-speed cameras, and 3D tracking systems. So to do this, to develop this concept, I worked with Hirano Sensei at Yamakawa Lab to test how the handwriting input looks and could be used. So here you can see some of the recordings of us writing in Japanese and in Arabic. So we tested basically what that would look like in the system, and then we coded and tested the gesture system. Each picture corresponds to a certain gesture, which is the GUI that Hirano Sensei developed, which then allowed me to build a system of interactions and test the speed and accuracy. Recording enough of this would give us preliminary data for word prediction, which will also aid in the speed. So, as you could see in the videos, the OptiTrack system in Yamakawa Lab uses retro-reflective markers to track and collect data of the handwriting and the gestures. So I realized that not only two fingers were needed, only two fingers were needed to write and navigate and interface, as you can assign the handwriting function to one finger and the navigation to the other. So they would kind of serve, like one would serve as a keyboard, and the other one would serve as a mouse, or like a replacement for something like a mouse, and you would navigate. So the pointer finger was actually assigned writing, as it comes the most naturally. If you ever imitate any kind of handwriting, you would kind of go like this. And the second finger, two fingers together is basically navigation. So this also meant that there was less switching time between the fingers because they're close together and it's only two. And using the 3mm facial trackers, which you can see here, they're tiny, I was able to use my fingers more freely when recording handwriting data. And I found that our hands as tools are the most intuitive to gesture and to write with. So they're already calibrated to you, and there is no learning curve. And also, the most important part, it's impossible to lose. They're attached to you. So this kind of aided in the invisibility concept. So when you write with your finger, we already know what we're writing. And we don't need a visual aid such as this. So you wouldn't need to see this because you already know your intention of what you're writing. So yeah, you don't need a visual aid to confirm what is being written. So I would like to show you how it works. The device recognizes the markers and the handwriting keyboard is activated. So that's at the top. And then after this, you can start writing in the air, and the device will recognize the word and predict the words or phrases that will come next based on your personal texting behaviors. So here is some examples of what this could possibly look like. And other than the intended use for Arabic speakers and those who are less able, this can also be used by people who already have a keyboard that they like or that they already use a lot. Instead, it can make life a lot more convenient, such as in faraway situations, like for a self-service kiosk or public spaces and shared services, such as like ticket machines, vending machines, and even cars. This is especially useful as it doesn't spread bacteria from fingers to shared surfaces. And the second one would be in situations that require silence. So like museums, trains, private situations. And the third one would be devices that are becoming smaller. And they are kind of foregoing screens. So this is suitable for small screens with less interface space, such as the Apple Watch and devices with no screens at all, like Google, Echo, that little thing. Yes. So to develop this, I had to start thinking about how the fingers would move. And so I made early marker prototypes to attach basically to your nails so that you wouldn't have to be too conscious of what's on your finger. So the wearable tracker was designed to use for testing. And although phones are advanced and they have depth recognition capabilities, they are still far from being compared to the LED OptiTrack system. They were developed because I wanted the markers to be seen from all sides. So this means that the trajectory of the track gesture or handwriting won't be disrupted as it is visible from all axes. And this will provide us with more accurate and smooth data. So this allows for more freedom when designing the gestures, and it's an adjustment to how humans behave and move. The gestures are supposed to feel as natural as possible, so it must be completely visible. I would also like to see how this non-touch high-speed input can be adapted to a long writing format. At the moment, this concept has been designed for short and quick replies, like when texting or using, your handheld devices. So I'm continuing the work on making this more innovative and speedy. Yes. So, thank you.
Hi. Thank you, Shireen Malawa. それでは、ここで一旦休憩に入りたいと思います。ちょっと時間が押してしまっているので、短めなんですけど、45分まで、約7分ほど休憩を取りたいと思います。その後また、あと2回のプレゼンテーションを、行いたいと思います。後ろの、あそこにあるカフェが、8時までオープンしているということなので、ぜひ、飲み物を片手に戻ってきていただければと思います。 それでは guys, please have seat. Yeah, we're gonna start again. それでは45分になりましたので、第2部のプレゼンテーションを始めていきたいと思います。続いてはですね、東大の生産技術研究所で、建築都市環境、それから風環境工学をご研究されている菊本先生の菊本研究室と、一緒にプロジェクトを行った、ファニーさんとそれからシエンさんの2人に発表してもらいたいと思います。
Hello, everyone. So Shiwan is going to start by introducing the lab we worked with, which is Kikumoto Lab. Yes, okay.
So basically for the research area, we are it's mainly having three area: wind, heat, pollution, which is spreading in building environment and urban area, and also basically two main technology they are using: one, simulation and measurement. So to be more specific, we are picking up like those four main technology, including dispersion modeling of air pollutants, monitoring of urban environment, numerical simulation of complex turbulence fueled by three-dimensional computational fluid dynamics, and also sensing of urban environment.
Thank you very much. Okay, so up. So my project is called Urban Cold Iceland. And just to give you a little context, I'm going to start by talking about how to match perspective from like design point of view and also Kikumoto's lab knowledge. Then, I'll follow by how I developed my idea and work you through the step. And then I'll finish with like how is the project now, and it's a work in progress, so it has to evolve still. So first of all, I think overall Kikumoto Sensei Lab have a lot of hidden treasures. And for me specifically, it really changed the way I looked at cities. In a way, it humanizes the city, with the wind becoming a sort of proof that the city is alive. And on the other hand, we have like the design lab perspective. I think usually the most common aim for design is to solve problems for humans. And when we started working with Kikumoto Lab, one of the first things we noticed is that everything is looked through the scope of architecture. And so I decided to kind of superimpose another scale on this, which is more human-centered. Sorry. I have to work with the mic and the paper and everything. So yeah, and this was really helpful in order to make sure that the outcome of the project would be a more tangible impact on people. So, yeah, another paper problem. Okay, I'll make it work. In the process of treasure hunting, my starting point was one of the concepts, which is called Urban Heat Iceland, and it's studied by Kikumoto Sensei Lab for a long time. Urban heat Iceland is defined as a phenomena in which urban areas experience higher temperatures than rural area. And as you can see, even inside of the city, you have different parts that are hotter than others. So one of the things that we're noticing today is that heat waves are becoming a big problem in city. And the truth is that I was hoping that today would be really hot. But I hope you can all recall last week heat wave. And yes, just make an effort, it's really hot, yeah. So I asked myself, how can we offer a sustainable cooling option to urban citizens living inside of urban heat Iceland? And I thought, if we have urban heat Iceland, then it could be nice to have urban cold Iceland. In my mind, a urban cold Iceland would be a cooling, resting place, a type of urban oasis managed by communities that offers us possibility to have a nice cooling break. The idea is to propose an alternative and a sustainable and more democratic alternative to AC in cafes and in malls, for example. So what could be urban cold Iceland? I guess it could be sort of a tent or a hut, a teepee. Maybe it's like a way to harvest coldness from rivers, or even a sort of like a curtain moving with air. Why not a network using ground energy to cool down air, or even like a sort of magic pipe that just like blows wind on the water? Yeah, but I went for this idea, the human fridge. So basically, it was inspired by this technology, which is called the Zeopot. The Zeopot is basically a technique to cool down vegetables, in very hot countries. A small pot is put inside a bigger pot, and in between you have a layer of wet sand. The chemical reaction is called evapotranspiration. The evaporation of a liquid on the surface of the pot evacuates thermal energy and cools the inside of the second pot. The wind has an important role actually, because it has to be dry enough to allow the transfer of humidity from inside to the outside. So to develop my idea, I had a 3-step process. The first one is that I was like, okay, we have this pot, maybe we can turn it into blocks. Did I switch? No, it's okay, sorry. We can turn it into blocks, and with those blocks, create like new spaces and modular rooms and a way to cool down. The only problem is that this would be actually a very humid and dark place. So it kind of didn't really work. Then I was like, okay, maybe we can have wind panels. Those would be lighter, and with them, we can overcome the humidity problem with entering ventilation in the space. And these were like only one layer of ceramics, so they're actually lighter, and we can orient them with wind, so that way you can create a airflow inside the structure. I had to like test if this was working, because the Zeopot is like a layer of ceramic and then sand and some ceramic again. So this time I had only ceramic. Also, I did like experimentation to see what would be the optimum size of each panels. So I had each time like I did some walls. You'll see them in a minute. And those walls have each time the same surface, but what changes is actually the size of the panels. So had a lot of gluing sessions. And as you will see, I'll just like make models. They're all over here. You can see them after. And yeah, the angle of each panel switch. And those are like the 3 different sizes that I tried. Then I had this setup, which was made with a fan and a thermic camera. And each time I was actually like spraying some water on the ceramic, so it's humidified. And you can see that the mist is actually imprinting on ceramic, and that's like something that I kept throughout the process, because I felt it was like a nice way also to play with like natural element, adding something to the aesthetic of it. So that's like a recording of me spraying water on the wall, and you can see that the temperature changed very fast. And we're actually able to have like a -5 degree difference. So that was working, and it was proving the fact that I only need maybe 1 layer of ceramic. And then I had to investigate how wind would look like. So that's like a CFD done by Kikumoto Lab, helping me on a very simplified version of my idea. And what it actually showed is that, let me go back. No, yeah. It showed that in the middle, you have a turbulence creating itself. And the problem is that I realized that the wind will be becoming hot and then kept inside. So it was not really working, because then it would create like humid and hot. So go back to the process. I had to find another solution. And this other solution consisted in separating wind and humidity. They cannot really work together. So I had to like figure a way to make the humidity go away and input some wind inside of the structure. And taking this kind of as a plan, I went to Kikumoto Lab and we had a discussion, and they explained me how it could work. And then this is like the first working models that I did. So the wind is actually harvested in the upper part of the tower, and then it gets inside. And there's like a sort of spiral that the wind follows. And those ceramics the outside shell is made in ceramic that is humidified. So then you have like evapotranspiration that cools down the inside tower and the wind. And when the wind is cold enough, there is opening that allows the wind to go in the heart of the tower. So that's creating like a major temperature difference, and it's actually cold inside. And you can see that maybe with people inside, the air will get a bit more hot, but because it's type of a chimney, then the hot air just like goes up and evacuates to the tower. So yeah, up, oops, sorry. So one important thing to look at this project is that it's still a work in progress. And after this, once I had figured the principle, there is like an infinite number of questions to answer and to play with. Up. The first one is actually the water, because I kept on saying that the ceramic has to be wet. But how do I achieve this? There are several ways to do it, and the truth is that I need to try them on like bigger scale models, so I might not have like one answer to give you, but there's maybe playing with rainwater. Of course, we can collect it, and then ceramic is porous, so there's maybe a capillarity effect that could be involved, and the texture could be made so that the humidity gets trapped. And I have also this idea that there's maybe a way to involve the community to bring water to the structure, a bit like when you need to water a plant. And of course, the fact that the water doesn't run continuously thanks to an engine means that you can control the water usage, and you can also keep the structure dry when it's cold. And now comes the fun part. So can it be made into other shapes? Well, actually, yes, because you just need to have like those two type of layers that overcoming each other and space for wind to go in between of them. So that's like maybe a space inspired by Kikumoto's simulation of wind, which more like showing wind flow and how it's working inside, with actually, yeah, with like smaller turbines disseminated on the structure. Then who is it using the structure, and where is it, and what is it? Like, what's the context behind it? But actually, it could be like a new bench typology. So that's like the simpler kind of idea where you just rest. But it could also become like a sort of a kiosk, which is more a commercial idea out of it. Or even like a bus stop. And bus stop leads us to like network. And I think I kind of want to finish my presentation of this idea of like, it could be really nice to have those towers or those spaces kind of disseminated in the city so that you can go from one to one and have like nice cooling breaks. Thank you very much. I need to thank so much people. I guess Kikumoto Lab. Thank you. The whole DLX team, Shiwan that was with me and is going to take over in 1 minute, and also my 3 colleagues from GAD. Thank you so much.
Okay, sorry to take so long. And right now, I'm presenting my project about urban fluid scope. And it is about a public dissemination of fluid phenomenon of wind and environment in the city. So my project starts with the process of understanding what is Kikumoto Lab's key technology. So after talking to Mr. Jia, Mr. Hu, and Ms. Chen from the Kikumoto Lab, I understand and pick up 3 key technologies they are working on. So looking at the huge amount of data and graphic information from CFD technology, I start to wonder how can we bring those core simulation and estimation technology to the public in a more meaningful way. So To maximize the ability of Kikumoto Lab's simulation and estimation technology, I imagine it to be the maximum scale. So in this case, what kind of scenario is like can allow to people to have a maximum scale of the experience? So apart from the experience that we all had, like looking down the city from the airplane, I come up with the idea that tourist telescope is the one that we allow citizens to look around city buildings and streets. So I speculate it could happen in the city skyscrapers for tourism, for example, Shibuya Sky. Kikumoto Lab's estimation technology with high resolution and real-time nature actually enables us to speculate this perceptual AI experience of fluid in urban scale. So as you can see, for the when they have the technology of the estimation and simulation, they are like we can actually in real time to kind of see the layer of pollutant dispersion and urban airflow in the street view. To further explain what is this urban fluid scope, I want to start with the part visualization. So first, I start with the question of how might the public perceive the CFD information. For me, if we want to like take this project more in a designer way, it's really important that we perceive this information not academically, but more aesthetically. So in this case, I want to bring up the structure of air pollution generation from the urban canyon effect. So in urban environments, those pollution, including gases and the pollutant particle matters, is emitted by automobiles, and they are kind of having negative impact on pedestrians. And also a decrease in ventilation performance of outdoor spaces causing by the high density use of urban spaces. So from this structure of the pollution created from the urban scale, I kind of want to like layer down the information of pollution and wind at the same time, and also to like kind of bring more awareness to how this urban structure has giving the kind of close connection between the pollution and wind. So my first things was doing kind of mimicking the house street, the most common crossing with 4 buildings that is like very high and having like less spaces in between. And when we actually layering those wind flow information on the streets and roads, and also dispersion of air pollutants on buildings facade, it actually creates a very aesthetical experience. And then from that, it's very important that we kind of have such a aesthetical experience while having awareness of how those pollution was like affected from the condensed urban structure. So this is like the part of the demo. Oops. It's actually emitted from the like digital projection display, so it's actually allowing me to. Oops. Okay, sorry. I think I cannot really show this video. Okay, so let's move on to the second part of perception. So after visioning how we might have a perceptual AI experience of fluid phenomenon in urban scale, I start to ask, so what? What is the next? How this cool visualization technology can make a bigger impact to people. That brings me to the question, how can we bring this to more people, and how can we engage more people? how can we encourage people to take action in better, having a better urban environment. That we actually, before we think nothing when we are actually seeing the street views, but after that we kind of like thinking about how is the urban flow, ventilation, pollution. So I want to explain from my working process of this. Oops, did I skip? Oh, okay, sorry. So I want to answer this question, I come up with a journey of finding how can we make our perception towards the wind and pollution that is invisible, intangible, and imperceptible to a more intangible, perceptible physical form that we and also the public can be aware of. So I'm going to explain with my working process of how I can translate my perception of wind and pollution towards a more tangible form. So I start with the question of how do we imagine and describe the wind environment and particles in the air today? And I also think about try to come up with multiple descriptive words. It could be adjective, emotion, color, property, and tangible metaphor. Also, second similar question, and it's more like imagine the texture of this. So I actually I didn't do it alone. I also do it with the Design Lab members together, and so that we come up with various texts of describing the air pollution and wind with different kind of words. Maybe it's also having Chinese words. Okay, so this is the journey of text and description. Next phase. Okay, next phase. So now you will be asked to sketch based on the description you had with simple geometrics, dots, lines, and curves. So after that, this one I kind of layering out all of the text, and based on that, I translate with pure geometric graphics. And then we are asked, we asked the whole lab members to choose from those graphics which fit their imagination most of the texture of wind and pollution. So this is the part of the sketch and graphics. Okay. Yeah, so the next phase was surface texture. Based on those graphics, we are actually further abstracting the two-dimensional drawing into a more three-dimensional texture, which can layer on a surface. So I call it surface texture. So so we use different materials to kind of mimicking what we are actually imagining about the texture of wind and pollution. So based on those whole process, I called it as tangibility translation. It has 4 parts of description, graphics, reflection, and materiality to gradually translate into a non-tangible word to a more tangible form. So I want citizens to communicate with each other about their perception towards wind and pollution spontaneously. And these are I imagine it will go through 3 process. First, translation. And secondly, we have the people experiencing those 2 types of the scopes, and then having another translation after the scope experience. So then we can actually understand in a tangible way that how CFD data visualization can influence our daily experience. Okay, so to conclude, it mimics the experience of sightseeing from skyscrapers with AR technology, layering the CFD information, and it expands to a program for us to evoke perception, what is invisible to the tangible and perceptible. Thank you so much.
Thank you, Fanny and Shen. 続きまして、同じく生産技術研究所で次は機能性ポリマーのご研究をされております吉江先生、吉江研究室と、共同した健太、それからヴェディカに、バトンを渡したいと思います。ちょっと10分ほど押してしまってるんですが、このまま続けて行いたいと思います。
Yeah, hello everyone. I'm Kenta. I'm a master student in the DLX Design Lab. I'll explain about Yoshi Lab, which is we collaborated, and after we present each project. Sorry for English people. I present my project in Japanese, but there's some English subtitles, so please enjoy it. Yeah. Then at first, I explain about Yoshi Lab. They are researching about adding novel kind of functions to polymer. And actually, we usually see polymers as a kind of tangible things, but polymers is actually the collection of single polymers. Then they controlling that's bonds and make some new novel functions and add to this. The example of the novel functions is a self-healing one or some biodegradable one. And I'll present my project called Chact, which aims to make letter writing set to shade sadness to separation into recollection. ということで、ここからは日本語で喋らせていただきます。チャクト、別れの悲しみを思い出に昇華することに寄り添う、レターセットと題しまして、私から発表させていただきます。まず最初に、動画の方ご覧ください。チャクトはこのような形でレターセットになっています。このように書いた後に、太陽光に少し当てると徐々に、このチャクト自身が劣化していきます。この劣化していく便箋を相手に渡すと、時間が経つとともに、as the weeks, months, or years pass, its color change, it eventually degrades. 日が経つごとにこのように劣化していき読めなくなります。この研究はこの養成研究室の皆様と一緒に行っており、彼らの研究が将来的に貢献できるかもしれない研究の可能性というものを提案するものになっています。そして、そうですね、このチャクト、先ほども申し上げました通り、別れの悲しみを思い出に昇華する、そしてそのプロセスに寄り添う便箋ということですが、どのような、コンセプトなのかというのを改めてご説明させていただきます。別れというのは、基本的には、いつも受け入れがたいものであり、これは癒したり、克服したり、あるいは程よく忘れたりするということが、この痛みに向き合うことに重要であると考えています。チャクトはこの劣化していく、徐々に読めなくなる、手紙自体がなくなっていくという特性を持って、時間が経つことを、実感してもらうと同時に、この少しショッキングな体験を通して、この手紙のことであったり、ちっちゃい一つ一つの出来事というよりも、あなたと過ごした、大切な時間をより強く覚えるようになるだろうというのがチャクトのコンセプトになっています。例えば、恋人と別れるでも、友達がどこかに引っ越していく、そんな比較的カジュアル、カジュアルかどうかはちょっと人によると思いますけど、カジュアルな別れから、もっとシリアスな別れまで、いろんな別れに、対して、役に立つものではないかと考えています。チャクト、ここまでお話を聞かれると、受け取る人だけにメリットがあるのではないかというふうにお考えになるかもしれませんが、各あなたにもメリットがあります。チャクトはこれ自身がいつかなくなるということで、あなたが普段言うのも照れくさいような、ちょっと素直な、褒めたり、ちょっとあれは嫌だったなとか、そういうことを書いてみたりするのにも使えるかもしれません。チャクトはこのように、 この普通の封筒とこの透明のポリマーでできた、便箋本体、そしてこれを覆う黒い、封筒で構成されています。でこの便箋自体というのは、スペシャルなタイプのポリマーで作られています。このチャクとこの、ポリマー、便箋自体は酸性の環境下で高速にって言っても、数ヶ月数年という単位なんですが、高速に分解するポリマーを使っていて、その中に光に反応して酸を発生する薬剤が、混ぜ込まれています。そのためあなたが手紙を書いた後に太陽光に当てるとチャクト自体が酸性環境になって、その時点から分解が始まるということになります。この分解自体は酸というのは、ただ触媒キャタリストとして進んでいくので、あなたが、これを例えばずっと持っておきたいと思ってもこの劣化を止めることはできません。そのため最初の時点の劣化が始まらないようにこのような黒い封筒を使っています。そしてこれはもっと、ハイレベルというか難しい話なんですが、もし触っても大丈夫なぐらい、弱い酸で劣化するポリマーが作れたら、温めると消えるインク、フリクションボールペンみたいなやつですねにこの光酸発生剤というのを混ぜて書いた後にこのようにドライヤーで温めると消えていくと。でもここのインクのところにはフォトアシッドジェネレーターが残っているので、日が経つとその部分だけが劣化して、また見えなかった文字が日を経つと読めるようになるということもできるかもしれません。でこのチャクトというプロジェクト、トレジャーハンティングと今まで、ご覧いただいたいくつかのプロジェクトと同じようにこのようにワークショップを行ったり、実験を環境を見させていただいたりという中をそのような流れを通じて作ってきたものですが、このプロジェクトは一番最初のクエスチョンとして、この自然分解、生分解することというのは、それ自体が価値だと思われがちなんですが、その自然分解することっていうことが、自然分解するだけじゃない価値を生むにはどうすればいいだろうかということを考えました。その結果、このような、とても高速に劣化するポリマーを作ることで、この劣化自体の価値を、上げることができるのではないかと考えています。この高速に劣化するポリマー、ちょっと長くて申し訳ないんですけど、この高速に劣化するポリマーは今すぐ彼らの研究の先にあるというものではありませんが、彼らの研究が将来的に貢献できる可能性のあるものです。このプロジェクトではそのような多様な可能性を探索して、一つの例として今まであまり研究対象というか、役に立つ知見、いわゆる役に立つ知見だと思われてこなかった急激に劣化するポリマーということが、何かの役に立つんじゃないかという可能性を提案しています。そして、そのような急速に劣化するポリマー、他にも、使い道がないか考えてみました。例えば超高速に劣化する付箋、これはあなたが忘れてしまうようなどうでもいいような付箋がそこらにペタペタ貼ってあるのをちょっと鬱陶しいので、そんな忘れちゃって全然やんないようなタスクを書いた付箋は勝手に消えちまえということで、そんなものができたり、あとはあるいは食べ物、卵とか、あるいは果物が熟した時に色が変わったりして教えてくれるパッケージというのもあり得るかなと思います。例えば熟し度合いであれば果物、種類によりますがエチレンを出すので、そういったものをトリガーにして反応させるということもできるであろうと思います。以上チャクトの発表となります。養成研究室の、アソシエイトプロフェッサーの中川先生はじめ、さまざまな方々の協力でこのプロジェクトができました。この場を借りてお礼申し上げます。ありがとうございました。There is my poster and there is a much more detailed English description, so please check it if you are interested.
Hello everyone. So, did you know that self-healing teeth of squid have regenerative powers to repair themselves in contact with water? And this has kind of served and inspired a lot of self-healing materials in wet environments. So the field of metamaterials inspired by biomimicry or nature has escalated possibilities for future material. And now that, and this can extend their functions by working with stimuli such as heat, humidity, temperature, etc. And before we understand what a self-healing polymer is, let's understand what a polymer is. Long chains of continuous chains of molecules are called polymers. And what a polymer that heals itself with unprecedented speed with an efficacy when cut, almost completely recovering its original strength within minutes. Sometimes it can be within just 1 minute. And it also kind of, when the fresh cuts come together, they heal faster. When two self-healing polymeric surfaces come together, they heal at much faster rate. So the Yoshi lab says it's like magic. So now imagine seeing a damage heal in just seconds. Isn't it magic? So how do such self-healing materials can change our world and daily practices around us? And it has already entered our world through applications in medical science, drug delivery, and space applications, and so much more. But there's so much yet to be discovered. So Yoshi Lab develops these polymers which are tough rubbers, stimuli-driven, and their degradation can be pre-decided. And while carrying on research with this kind of speculative material, I wanted to see how existing traditional arts and crafts could add new dimension to these 2D materials. Can they be structurally made 3D, or can they be made upcoming 4-dimensional? And how can this extend their performance and functionality? And also and how to instill an idea of creativity and visual thinking in the lab, a basic science lab. So we did a lot of co-design workshops with the scientists themselves. This led on to answer these questions of how the speculative and traditional can come together. I went inside the IISS Tachi lab. So what Tachi lab does is uses origami and kirigami, so to construct novel functional systems. And by understanding the relationship between its shape and form and how it's cut, the patterns, and they're trying to make, using geometric modeling and algorithms, they're trying to create new functional systems and even phenomena. So what is kirigami? So it's a lesser known Japanese art form of cutting and folding paper to realize 3-dimensional structures. And this has now entered the world of metamaterials, where it's used to make 3-dimensional shapes, and enhance its properties, enhance its functionalities. And now when kirigami comes to with the self-healing polymer, it kind of enhances it makes it ultra stretchable, it makes it highly elastic, and also makes it very highly sensitive. And sometimes it can also make the polymer go 2000% more stretchable. So while co-designing with these labs, we understood that how the bistability is an attribute of kirigami, which makes the pattern stable in 2 equilibrium states. And this kind of stability can be applied in self-healing polymers also, because it's an elastomer, and it can be kind of used to make because the bistability depends on the thickness and how the material is formed, so it can be applied on self-healing polymers. And therefore, to look at how the cut of the kirigami works and how the pattern is formed, we can see how we can delay the healing of the self-healing polymer, which doesn't exist right now. It's very speculative. So to understand what the need was, how might we give material scientists a new visual tool to reimagine functionalities and applications of self-healing polymers, and use kirigami patterns to facilitate positive, irreversible reactions by deploying delayed healing principle. So what is this hypothesis? So the threshold hypothesis means that my project is an investigation into the principle of selective and delayed healing, that in order to see how stimuli-driven polymers made by the Yoshi lab can heal at various threshold levels, the opening and closing of the voids and slit allows stimuli-sensitive self-healing polymers to be configured in a way that they perform a certain function prior to the healing. And the threshold can be set to either its lowest point or the highest point of the stimuli. So what is Polytile? Polytiles give researchers a visual framework that provides material scientists with new tools and investigates new approaches and applications whilst they're creating self-healing polymers in the lab. And what it does is it adds purposeful investigation to kind of scope the scenario, the context, and application before the research, create it in the lab using a selection of parameters given to them, and also test it within the lab, kind of reiterate on the process. So this is how it will be used. So polymer researchers are known to work and make materials with desirable qualities. And therefore, I wanted to leverage this careful selection process that goes in the lab. So by bringing this framework to the lab, I wanted to see how this researchers can be playful with it and use the parameters, understand it, and also understand how the delicate geometry of kirigami patterns to make use of this kind of framework. It can act, they can choose the behavior here where the self-healing polymer material can be designed for. The behavior can be either absorb, exchange, heal, flow, collect. And they can also kind of build a context around, okay, this might be used for certain kind of application. Based on this, they can select the geometry, and that's how the card will look like with all the possible parameters that will help them in the making of it. They can also set the stimulus that will activate the healing process and what the threshold will look like, and that's how they optimize it. So this is the real self-healing polymer, and that's how they're cutting it and they're making it. And so this kind of thing will look like in the form, it comes in the form of a dashboard and a simulator where they can actually see and kind of control the degradation and the self-healing process. So the parameters of making would be behavior, context, geometry, stimuli, topology, and optimization, leading to degradation after it. And these are the 4 stimuli that Yoshi Lab works with, can come forward, and they can use with. This polytile will be polytile will be used as a dashboard, a simulator that will allow easy visualization in the lab, and that's how the cards would look like, with the possible outcome, possible application, context, and the idea of like how they'll be made, how the structure will look like, where this can deploy it. So this now taking an inspiration from nature again, and how it kind of leads us to regenerative solutions. I propose seeing these pattern polymers as membranes, similar to those found in this nature. A membrane functions as a selective barrier, and this can allow us to protect, collect, resist, and also allow entry. So one of the possible applications can be how it can be used in floriculture, cold supply chains, and used as a packaging material that heals when the temperature kind of rises and it has to lock in moisture. And there are several ways this polymer, so this is how it might heal based on the threshold set for the temperature as a stimuli. So this is just one of the many applications that are yet to be discovered with these speculative materials. And with Polytile, I wanted to contribute to the material research by providing creative and visual tools to the scientists. I'm looking forward to seeing how these frameworks like Polytile can help us learn more about the resilient and morphic metamaterials like the self-healing polymers. And here is my display where you'll understand the framework and look at the functionalities, how the movement works, how the structures are deployed in. So yeah, feel free. Thank you. And thank you to the lab and Yoshi and Tachi lab, both, all the research students, and Ruya Toyaka from the Tachi lab who we collaborated on making the kirigami patterns with, all my mentors and my wonderful DLX family, Fanny, Shaolin, and Maroa. Thank you so much, and thank you all for coming here.
ありがとうございました。Thank you everyone for the great input, output. 今日のスピーカーは全部で6名ということで、 それぞれ山川研究室、菊本研究室、吉井研究室の3研究室と、共同で約2ヶ月、やらせていただいたプロジェクトの発表になります。で、今回ですね、この DLX デザインラボの全体のディレクターのマイルス・ペニントンさんにお越しいただいているので、ぜひマイルス先生から全体へのフィードバックをいただけたらなと思います。
Thank you, maybe we've been sitting down for long enough, so I won't say very much, but get you guys to, when we wrap up, we get a chance to talk to the people that have been presenting today. But yeah, maybe I'll say a few words. First off, we've heard a lot about the word treasure hunting today. The title of today's episode is Treasure Hunting. I thought I would explain where it comes from. So when we were planning to do the Design Lab back in 2016, myself and some colleagues from the Royal College of Art in London came over to visit IIS Tokyo, and we went on an amazing tour of many of the labs, some of them that the speakers today talked about. And it sounded an amazing opportunity to build a design lab in the heart of this technology research institute. And our final question to the team before we left was to Shunji Yamanaka, professor of Tokyo, who's worked there for many years, and he's an eminent industrial designer. And we thought we better ask him, what is it really like being a designer buried inside, deep inside a technology institute? And so we asked him that, and he sat there for a moment and thought about it, and then he said, it's like treasure hunting. So we thought, okay, this has to be a kind of catchphrase and a methodology of what we do. What we see treasure hunting is that inside academic research labs, there is really valuable knowledge and know-how. But somehow in the world of academia, it's kind of hidden from the general public. So we see that treasure as the things that we go hunting for. And that might be to create new product or service ideas, or it might be to help the researchers see their work in new ways, or it might be simply to bring it out to the general public. So the treasure is there, is valuable things that we think are worth discovering. But I often think sometimes the phrase works the other way around. Treasure hunting it's the treasures who are doing the hunting. And I think you saw today 6 treasures. So in Design Lab, we love to build a really international team. And the point of doing that is to bring diversity and new thinking to the projects. So diversity brings difference, and we really enjoy to see different approaches and innovations come out from these projects. So I think today we have 4 from London. So yeah, come up here, guys, because you should take another round of applause. Vėdika, Maroa, Fanny, and Shaolin. And we also have 2 home treasures. Come on, guys, don't be shy. Kenta and Siyuan. So these guys have only been working on this project 2 months, and they had plenty of other things to do in the background too. So well done for your incredible efforts. Treasure hunting is twofold. It's a design project, and it's also a diplomatic mission. So these guys have to discover the treasures and then negotiate with the treasure owners, and build a relationship that goes from visiting designer to collaborating innovators. So I think after 2 months, I think you guys know now probably how to launch an even more successful mission in this vein. And we're really happy that you guys have done that, especially the 4 who've come over from London. And yeah, Kenta and Shiyuan have another year, well, not quite a year, but they have plenty of opportunity to put their experiences to practice too. So we'd love to hear your feedback, but you've been sitting down a long time, so let's wrap it up now. As you've noticed around the room here, we've got posters and little mock-ups and prototypes of all the students' work. We'd love it if you could come up and talk to them, ask them questions and find out more about their work. So we'll do that. We've got to think about half an hour of time to do that. In the meantime, I'd also like to say a big thank you to Nomura-san. Where is he? He's hiding at the back there, maybe somewhere. Oh, there he is. All right. So this gentleman, I think I met him first in London in 2015 or something. He was telling me about the dream of building this place. And of course I was like, yeah, whatever, yeah. But here we are now. Thank you so much for lending us this space, and we hope we come back again. Thank you, everybody. So yeah, let's break it up, and please come and talk to the students about their work. And thank you guys for joining us tonight. Thank you.
ぜひ9時頃までここで、ポスターセッション、それから自由な Q&A にしたいと思うので、ぜひトレジャーハンターの皆さんに質問をしていただければと思います。